It's the dream of every 3D printer owner. Putting that machine to work, earning money for you while you sleep, and turning your hobby into a side hustle or even a thriving business. But of course, because this dream is shared by so many, it's become more difficult than ever to create products that actually stand out. Gone are the days where you could list flexi dragons or other useless junk and gain customers from the sheer novelty. No, it seems like all of the 3D printing businesses that succeed these days are investing tons of time into R&D, CAD, and developing truly unique, useful, and highly polished products. But what if there were another way? A way to leverage not just 3D printing, but also laser engraving to make unique, functional products. Sure, the market for customized laser engraving is no less crowded than that of 3D printing. But what if there were a way to leverage the strengths of each technology individually to create unique, high-value products that outshine the competition? In this video, we find out. I'll be exploring the possibilities of combining these two technologies together to try to come up with some real, practical products that anyone can offer. And by the end of the video, I'm going to try to actually sell some of these products as a proof of concept. Will I succeed? Or end up wasting an entire week of my life? There's only one way to find out. Let's get after it. Before we dive in, I think it makes a lot of sense to hit pause and think for a moment about what exactly each of these technologies is good at and what it's not. That way, we can develop our products and our manufacturing processes around those benefits. So first, let's start with 3D printing. Now, I know that most of you are very familiar with it and its strengths and weaknesses as a technology, but do stay with me because from a business perspective, the pros and cons are a little bit different. For example, let's talk about the strengths of 3D printing from this perspective. First, there's the ability to create batches as small or as large as we need. Now, this also means that we can produce different colors of our products without having to commit to a minimum order quantity for each color. Additionally, we can create geometries and features that would just be impossible with traditional manufacturing. Everything from undercuts to embedded RFID tags and just insanely intricate surface details. The weaknesses? Well, there's the weakness. 3D printed parts aren't nearly as strong as injection molded ones, and they're also not as smooth or as visually appealing, especially if we're talking about 3D printed text. Sure, you could install a 0.2mm nozzle on your tool changer, but still, you'll never get perfectly crisp resolution by melting beads of plastic onto one another. So next, let's look at lasers. In this case, blue diode lasers and infrared lasers, like the two on the Xtool F2. And right out of the gate, I'll address the major weakness. Lasers are essentially limited to two dimensions, X and Y, or, two curved dimensions if you use something like a rotary extension. So anything that you want to actually build out of a laser is going to need to be assembled out of two-dimensional parts. Now, this is true whether you're using them to cut, score, or engrave materials. But when it comes to strengths, there are quite a few of them. First, there's just the sheer speed. Because they use a high-speed galvo instead of a gantry to move the laser around, these types of lasers are extremely quick to process anything but the most detailed, high DPI images. We can use that to our advantage. Additionally, they have a wide range of applications. Not only can we laser etch wood, but also plastics, metal, fabrics, leather, and much, much more. And of course, there's the resolution. Simply put, no technology out there, not even a $20,000 UV printer, can compete with the level of detail that a laser can produce, and certainly not at the same speed. Finally, there's repeatability. Whereas 3D prints or CNC operations can fail pretty frequently, a laser can be set up and run again and again and again and again without any drama. They can even be set to churn out batches of the same design, but with different parameters, using nothing more than a spreadsheet and some variables, which just isn't possible with today's 3D printing slicers or CAM software, at least not that I know of. This is really powerful, not just for personalization, but for things like serialization and customization as well. Ultimately, these are all reasons why lasers are used in so many of the finished products in our daily lives. And I'm already thinking of all the different ways that we can take advantage of these Advantages. Think, for example, about leveling up our products with serial numbers and manufacturing dates, or limited edition products with the production number out of 1,000. The possibilities are very much endless, and they're simply not practical in a 3D printing only workflow. But of course, it's not all sunshine and lasers. Get it? Because never mind. Because there is some prep work and research that we're going to need to do before we start developing our products. First and foremost, there's choosing our filament type, brand, and colors. And if this seems pretty important for your average 3D printing business, it's absolutely paramount for anything involving lasers. Simply put, every single filament out there is going to behave differently under the laser based not only on the material type and the color, but also the brand. Different brands use different pigments in different amounts, and that can cause one black PETG to laser beautifully and another that looks the same to the eye to come out just awful. Fortunately for us, this particular laser, the Xtool F2, has two different wavelengths, both blue light and infrared, and their fantastic software suite, the Xtool Studio, makes it really quick and easy for us to generate customized test patterns for both wavelengths in seconds. And that's important because we're gonna need to do a lot of that testing for every single filament type and color that we want to offer our products in. Now, I won't spend too much time on this because both myself and Stefan from CNC Kitchen have done videos about this in the past, but suffice it to say that our decision to use lasers does limit us somewhat in which filaments we can use. TPU, for example, is generally a no-go, as are light oranges and yellows of pretty much any kind. But you really never know until you actually test it. Additionally, we are going to want to design around the particular laser setup that we have. On the one hand, the Xtool F2 not only allows me to remove the base plate and lift it onto larger objects for engraving, but it can also be upgraded with a slide extension to expand my working area, or even a rotary attachment to engrave curved objects. But still, if we're going for volume, scale, and efficiency, we're probably going to want to design all of our products to be processed in the same way. For example, all of them on the slide extension and ideally lasered on only one surface, rather than spending a lot of our time clamping and unclamping parts or moving the laser around or installing the rotary extension. You get what I mean. By the way, this video is brought to you by Xtool, the makers of this absolutely gorgeous laser that you're gonna see in action throughout the video. So if you're in the market for a laser, be it a fiber diode one like this one or a production grade CO2 laser, make sure to check them out. This unit costs literally half as much as the other fiber laser that I tested on the channel previously, which will make it a whole lot more realistic for you to recoup the cost of, either personally or professionally. So we'll leave a link in the description, or you could just scan this QR code appearing on screen now. So with all those considerations in mind, it's time to start brainstorming products. And this is my favorite thing to do as someone who's been an entrepreneur all their life. And right out of the gate, I already have one that I think a lot of you are gonna like, and which could actually sell really, really well on places like Etsy, despite being super easy to manufacture. So you know how everyone from YouTubers to woodworkers to makers in their home workshops, they all love these husky style tool carts? I'm working on one right now. So hear me out here, okay? Custom labels. I know, you're thinking to yourself, why not use a label maker? Well, I've tried with multiple different types of label maker, and they always come out ugly as sin or peel in the demands of a workshop environment. Plus, you can't easily peel them and move them if you ever decide to rearrange the drawers. The glue just won't stick more than once. And the same goes for vinyl lettering. That's basically impossible to move. Okay then, you might be thinking, what about cutting and lasering some thin steel labels? Well, you could do that, and I've tried, but they don't conform to the geometry of the handles. And if you glue them on, they always seem to get bumped and fall off. Magnets? Well, those are out of the question because at least on my tool cart, the handles are made out of aluminum. So here's my pitch, all right? We design and 3D print these kinds of clip-on labels that are removable and easy to slide around, but that perfectly conform to the geometry such that you'll never bump them off. You can slide them, rearrange them, move them, or replace them however you want, whenever you want. And because they're 3D printed, we can offer them in a wide variety of colors as well. But why lasering? I mean, why not just multicolor 3D print them? Well, for a few reasons. Number one, it would take way more time for an inferior product. Because of the shape of these labels, it's not as simple as just changing the color on the top or bottom layer. If you want them strong enough to not snap when they're flexed into place, then you're going to need to print them standing up. And that essentially means changing colors nearly every single layer. Plus, you would have to go into the slicer and manually edit and position each one of the labels for every single customer if you wanted to offer customization, which would just make it way too labor intensive. You also could basically never keep any kind of inventory. You'd have to manufacture just in time for every single order rather than batching your labor, which is super inefficient. But with a laser, there's no issue. We can just batch print hundreds or even thousands of these clips in a handful of colors that customers might want, and then just store them in bins. When a customer orders, we toss, say, 20 of them onto the slide extension on the build plate, and then we make use of the batch processing feature in Xtool Studio. That allows us to import a CSV file, which I'm pretty sure Claude Code could write a script that would just connect to our web store and automatically generate that CSV for every single order. It then automatically places and arranges the text from each of the spreadsheet rows onto the clips, even if they're randomly placed and misaligned. And from there, we just hit a button, fire off the laser, and about 60 seconds later, we have a batch of gorgeous laser-etched labels ready to ship. Personally, I think these are really, really cool, and I'm gonna be putting them on all the drawers of my toolbox. And I encourage some of you out there to take this idea and design for your toolboxes, or go down to Harbor Freight, measure all those toolboxes, and generate a bunch of different models. These are so cool because they use probably 10 cents worth of PETG-CF in this case, and I have a feeling that you could easily sell a 20-pack of them for like $19.99 or maybe even more. Another idea I had was to customize and personalize some of my favorite 3D printed measurement devices. Actually, on that note, now's probably a good time to say that just for the illustration purposes of this video, I'm going to be using some other people's designs just to demonstrate the ideas. We'll link to them and give credit down below, and later on in the video, when I actually try to sell some of these products, I won't be selling any of the ones that use other people's IP. If, however, you're developing your own products, then you have a few options. You could either A, design your own from scratch, B, purchase commercial licenses for any models that you want to use, or C, only use models that are full Creative Commons or MIT licensed, which would mean that they allow free commercial usage. And we'll cover some of those ideas in just a second. In any case, back to the 3D printed measurement devices, here's why I think that these will make a great product. First, they are super easy to print. They take very few print hours, and there are minimal opportunities here for print failures like supports or overhangs. They consume almost no filament, and they require zero packaging labor or even packing materials besides maybe a padded envelope. Second, like I mentioned earlier, most of the successful 3D printing businesses that I see online all involve tools, workshop gear, or tool-related accessories. And this would capitalize on that clearly thriving niche. Third, it's something that is very well suited to 3D printing. The holes and cutouts of these designs mean that injection molds would need to be a little bit more complicated and require things like undercut, but they're no problem for us to 3D print. In fact, because we're 3D printing them, we can even offer these in all of the popular tool brand colors. You know, like Makita, DeWalt, Milwaukee, and Ryobi. And fourth, it's something that really benefits from the added polish of laser etching versus 3D printing. Not only is the laser etching much cleaner and clearer to read, but using the batch processing with variables feature that I mentioned before, we can easily customize this product to add the customer's name. Heck, we probably could even sell these in bulk packages of like 250 for tradesmen or engineers to give away as custom business cards, if we offer the option to laser etch their information onto the back of the cards. Now, I think this is an incredibly cool idea, and apparently it's a completely untapped opportunity because I actually couldn't find a single competing product on Etsy. And I looked. So for all these reasons, I think that this is going to be the product that I'm gonna try and sell on either Etsy or Facebook Marketplace. I will need to either reach out to the designer, Gulashoop, and ask if I can buy a commercial license, or I'll just spend an hour or two designing my own version before it goes up on sale. But that's a problem for future Jonathan. And honestly, that's just one permutation of this idea. I'm still waiting on the slide upgrade for the F2 to be able to etch larger stuff, but I want you to imagine custom rulers for Gridfinity, Multibin, Multiboard, Milwaukee Packout, or any other system out there. I actually went ahead and checked for you guys with the team over at Multibuild, and they are enthusiastically in favor of users selling their own upgrades and accessories for the ecosystem. Or here's another thought. My mom is like really into sewing, knitting, and crocheting, and I bet it would be really cool to design some custom rulers for her to measure her stitches for the most common weights of yarn, instead of always having to count them manually. In fact, because the laser etching is so flexible and customizable, we could literally ask the customer to count their gauge, which is the density of the stitches, every single time during checkout, since that is different for every different knitter. And we could then make them a one-of-one custom set of rulers that match their knitting style for every single one of the yarn weights that they use. I don't know, I think this is really, really cool. The sky, or rather your creativity and entrepreneurial spirit, are really the limit here. Heck, I even used Claude Code to just code up a custom feature script in Onshape so that I can generate any kind of custom ruler with any kind of spacing that I want, just like that. And what's perhaps coolest of all is that because of the flexibility of laser engraving, we could essentially print or even pre-cut a bunch of rulers out of acrylic or wood, and then we would just keep them in a shelf until we got an order. And then only when we got an order would we customize and etch the units, from Gridfinity to crochet stitches to multiboard, multi-purpose inventory. Now we're thinking like enterprising business owners. Speaking of Gridfinity, I mentioned earlier that one could choose to sell Creative Commons or MIT licensed files for a profit, and so it only seems right at this point to mention Gridfinity. For those of you who don't know, Gridfinity is 100% public domain, and you're completely free to sell it should you like. In fact, it turns out that many people do. But one thing that's always bothered me about Gridfinity has just been the labels. I feel like you can't win either way. 3D printed labels, well, they just look like poo. Vinyl stickers, well, they're not practical at this scale. The closest I've come has been a label maker, and honestly, the clear labels from my Dymo look pretty good when they stay on. But unfortunately, there's just no way to bulk produce them with like a spreadsheet. And typing on this thing is an absolute pain. So I actually recently decided to buy a dedicated label maker for Gridfinity, which allows you to import a spreadsheet into the mobile app and then only produces 40 by 12 labels. And then I realized that you can't print on clear labels. So it's kind of been sitting in the drawer ever since. I do think, though, that the label maker option is still a pretty good opportunity as a product upgrade option if you're selling Gridfinity, because they are fast and cheap and easy to produce, and they are more flexible than permanently laser etching your bins. But that got me thinking, a lot of the hardware that we all use and store in our Gridfinity bins is pretty standardized. M3, M4, sometimes M2, or, if you're in America, 36/458 of a foot, or however the hell my former countrymen measure stuff. The point is, what's to stop you from creating unique sets or kits of Gridfinity? For example, a large bin or set of bins covering every M3 size, or every JST-PH 2.0 connector, or every wood screw from 10 to 50 millimeters. And then you could laser etch those to make your listing stand out in a sea of generic Gridfinity bins. Add on color match tool brand colors once again to go even further. And for the final coup d'etat, you could make completely custom Gridfinity products. I, for example, designed 2 massive bolt sorters for M3 and M4 hardware after I was inspired by the popular design from Layer Lux 3D. Now currently it uses multicolor 3D printing, but that has one flaw, besides, the time and waste and needing a 3D printer that supports multicolor. That flaw is that you have to print it on a relatively smooth build plate, face down. Otherwise, the screws have a tendency to get stuck on the textured surfaces. Plus, there's the usual caca-looking text, especially if your filament has high transmission distance. But okay, enough talk about Gridfinity. I'm sorry. You guys know how I get about my favorite topics: Gridfinity, open source software, and plastic recycling. What? You guys thought that we could go a video without me mentioning recycling plastic waste and 3D printed parts? No, mon ami, because here, again, we actually have a really cool opportunity to level up and customize our products. All right, bear with me here because I've got a little bit of a spiel. So over the last 2+ years of my journey towards turning failed 3D prints into usable filaments, 3D prints, and various parts, I've learned a whole lot. Namely this: recycling plastic is hard, annoying, and very expensive. And that's why so many companies and countries don't even bother with it. Virgin plastic will almost always be cheaper, a lesson until there are some major changes to things like regulation or the way we produce energy. The bottom line is, the only way to make plastic recycling truly economical, especially for us small potatoes, is to add enough value to the finished product that you can justify selling it for a reasonably high price that covers the labor and the effort. Now that value can be the story and the social good element of recycled plastic, but oftentimes that's just not enough. But as we've been talking about throughout the entire video, with a little creative lasering, we can add a lot of value to our otherwise meh-looking recycled products. And in so doing, we can probably bypass a lot of the challenges of plastic recycling. For example, instead of dealing with the hassles of contamination, extrusion, pelletizing, and re-extrusion, we could just make simple plastic sheets and then use a combination of blue light laser and infrared laser to just make all manner of recycled products. From custom engraved coasters to name tags, there's no shortage of ideas out there. And here's the really cool part that I discovered while prepping for this video. Remember how I warned you earlier on that you need to be really choosy about which filament and color you use for laser engraving? Well, turns out that because recycled plastic like mine is often an amalgamation of so many different plastics with so many different pigments, that issue pretty much goes away. I mean, check out these examples. They're all different mixes of different regrind from 3D prints, but believe it or not, I was able to laser engrave all of them with the exact same settings. Now this to me actually gives recycled plastic a major advantage over virgin material, but only if you're willing to find ways to process it. But now, the moment of truth, because these are all nice ideas on paper, at least I think they are. But there's a common saying in entrepreneurship that no business plan survives first contact with customers. In other words, you never really know what the customer wants until you get out there and actually start talking to them or trying to sell them your product. So now let's switch over to future Jonathan and see what he's been up to for the last week.
All right, I'm back. So at the end of last week, as I was going out of town, I took two admittedly very last-minute approaches to selling my products. First, I took some of them over to the very tiny corner hardware store, which was honestly going to be closed most of the weekend anyway. But second, I put up a very quick listing on Etsy just to see if I got some traffic and interest. I know, not the best proof of concept, but I'm already trying to get another new business off the ground. So between that and family and our video production schedule, I just don't have any more time for a more in-depth test. I'm sorry. Now, unsurprisingly, my display at the hardware store got moved the very next morning when a different employee came in and had no idea what it was. So that was a bust, but they did tell me that they could easily see themselves selling a product like that. And they told me that they were very confident that it would sell at the actual nuts and bolts store at the south of the city. So if I were to take the whole local sales approach more seriously, that would definitely be my next step. As for Etsy, I didn't get any sales. Again, not surprisingly with the very limited marketing that I did. Plus, I do probably need to find a way to lower the shipping price. Still, I did get some organic views just from keyword optimization, so I don't think that this idea is completely dead either. In fact, while researching the competition for this product, I found out that one of those very successful 3D printed tool accessory businesses that I mentioned earlier literally just added basically the exact product to their website, except instead of laser etched 3D prints for say $5, it's laser etched anodized metal for like $38. And despite being listed on the website as a brand new release, it already has 192 5-star reviews. So that to me is a pretty strong signal that there is a great market opportunity here. I just, probably need to spend more than an hour combined on product development, strategy, and marketing. But because I already have my hands full, honestly, I welcome and invite any of you who are interested in starting a 3D printing business to just take this idea and run with it. If I had to take another crack at this though, I'd honestly probably go the route of the recycled plastic. For me personally, that's just something that I'm passionate enough about that I would actually enjoy the time and labor of handcrafting the products. And while my initial tests still do need a lot of refinement, I do think that using a laser like this one could really level up the perceived quality of any recycled plastic products and just make them much more marketable.
On that note, if you are interested in plastic recycling, you're definitely going to want to check out a recent video I did where I used a desktop injection molding machine to turn my failed 3D prints into gorgeous injection molded parts, which now have a very handy QR code or TNL logo on them thanks to the Xtool F2. I'll go ahead and link that video right here. And hey, if you enjoyed this video, I would love it if you subscribed. Somehow, 70% of you still haven't clicked on that one button, and well, it would mean a lot to me if you did. That's all for this week, but I'll see all of you on the next layer.